morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. As a part of ground improvement techniques, today we are going to understand about the modification at depth by earth grouting. This is our topic. Coming to the modification point of view for ground improvement techniques, the modifications comes under various, it requires various parameters and understanding the various properties of the soil and what are the desired properties are going to convert as a required construction properties. So in that process we have a different kind of modifications which are going to choose dependency. So coming to this, earth grouting. This is also one of the ground modification technique which is involving the injection of a fluid like, it is the injection of a fluid like material into the ground to improve the soil properties, improve that particular ground properties. So in this we are going to apply used in construction, tunneling, dam construction and soil stabilization also. In this lecture, we are going to understand these are the objectives of the grouting. In this, we are going to increase soil strength and load bearing capacity, reduce soil permeability and water igneous, control soil settlement and improve soil homogeneity. These are the objects we are going to understand in our grouting. In this, various types of groutings are there, that is permeation grouting, compaction grouting, fraction grouting, jet grouting, rock grouting. These are the various types that modification at depth by earth grouting. So in these permeation grouting, compaction grouting and fracture grouting, jet grouting, rock grouting, it depends upon the type of the soil and on what depth we are going to conduct this grouting and which type of soil it is and what are the parameters we are going to enhance, what are the properties we are going to enhance is the criteria for selecting the grouting. What are the various parameters which are going to involved in this grouting? The one is ground materials, grout properties, injection techniques. These are all the parameters which are going to involve in these modification at depth by earth grouting. So coming to the grout materials, in these grout materials, cement based, chemical and particular. So these are the different types of materials we are going to choose for this grouting. So coming to the cement based grouts, we have to consider the materials. Those are Portland cement, microfine cement. Coming to the chemical grouts, sodium silicate, acrylate, polyethylene, these kind of materials we are going to consider. Now coming to the particulate, so that is comes under fly ash, specific. It is nothing but specific, that is fly ash, bannotinite. These are the some of the materials which we are using, these kind of parameters which are going to involved in our grouting process. Coming to the cementitious grouting, Portland cement grouts, it is the most common, providing high strength and durability. Microfine cement grouts comes under used for finer soils, whenever the finer soils and rocks offering better penetration for this microfine cement grouts. Bentonite cement grouts improves workability and reducing shrinkage. In this, different kind of material has its different specification. So based on the lead to the or getting the desired property, we are going to choose grout material. So in this, coming to the Portland cement, when we are using it, means we are providing high strength and durability point of view. Coming to the microfine cement grout, It is used for finer soils and rocks offering better penetration. And bentonite cement grouts improve workability and it is going to reduce the shrinkage. Now move on to the chemical grouts. And different number of chemical grouts are available. It depends upon the which type of property we require. Based on that, we are going to choose the chemical grouts. Sodium silicate based grouts. When we are going to consider the sodium silicate grouts, it is rapid setting. Whenever the setting is rapid conditions, we are required for various reasons. In some conditions, it may affect the construction schedule. The rapidity is required. Such type, we are going to choose these chemical grouts. And effective in reducing permeability. Effective reducing in permeability. Next one is flexible, durable and effective in water cut. So it depends upon the which type of design we require for that particular soil. We are choosing the which type of chemical is adaptable for this particular grouting. Resin grouts, XP resins, polyester resins, it depends upon the high strength and chemical resistance and fast setting and good adhesion properties. So these are all the parameters which we are going to understand in our considering the materials. So like that we have to understand this grouting. Now move on to the clay grouts. In these clay grouts, we are used for sealing and creating barriers in permeable soils. So in this type of clay grouts, so type of material comes under clay, we are used for sealing and certain barriers in permeable soils. Grout properties, viscosity, setting time, strength, permeability are the properties of the grout. Affects the ease of inspection and penetration. We are going to understand these grout properties. Coming to the setting time, determines the working time and the time before the ground can be loaded. Coming to the strength point of view, the hardening grout must provide sufficient strength to improve the soil. Coming to the permeability, reduced permeability helps in water control and ground stabilization. We have to understand which type of property we require. If you thought reduced permeability means whenever the water control and the ground stabilization is required, in that particular condition we are going to concentrate on the permeability property. It means the reduction of permeability helps for these both water control as well as the stabilization, ground stabilization. We are concerned about the required strength. In that particular point of view, we have to improve the what is the required or sufficient strength to that, getting that sufficient strength to improve the soil. The hardened ground must provide in such cases. Coming to the setting time, it determines the working time and the time before the ground can be loaded. Like this, we have to understand the various grout properties. Coming to the injection techniques, in these injection techniques, single stage grouting, multiple stage grouting, pressure grouting are available. Coming to the injection settings, in single stage, or it belongs to multiple or it belongs to pressure, it depends upon the once the operation requires continuous, we are going to do this in single stage grouting. This is the one of the technique. In injection grouting stages, to achieve better control and higher efficiency, we are going to choose multiple stage grouting. Coming to the pressure grouting, use high pressure to inject grout into tight or for deep formations. We are going to choose this pressure grouting. Coming to the equipment, for choose the equipment also having different types of conditions we have for choosing the equipment. Coming to this drilling rigs, for creating injection holes, we are choose drilling rig equipment. For injecting ground into ground, we are using pumps. For preparing grout mixtures, we are using these mixtures. And to deliver grout to the desired depth, injection pipes we are going to choose. Coming to the grouting design consideration, in this we have to consider different kinds of parameters. In that, first thing we have to do is the investigation. The geotechnical investigation helps us for better understanding the scenario of that particular locality and the requirement of the locality. What are the things we have to do is give the clear picture in this geotechnical investigation. What are the further steps are required? What kind of approach gives the better results? These are all comes under in this geotechnical investigation. In this, soil and rock properties, grain size, permeability, compressive strength and test existing whatever the features are there, we have to understand in these all these properties. The first we have to understand the soil properties and the next one is groundwater condition. In these groundwater conditions, we have to understand the where it presents, how much depth the water table is there, on which pressure and how the flow rates are there. And these are all the things we have to understand in this geotechnical investigation. The next one is the grout selection. It depends upon the compatibility with ground conditions, strength and durability requirements and also the environmental impact. In this we have to understand. So now coming to the compatibility with ground condition, ensuring the grout can penetrate and react appropriately with soil. Strength and durability requirements, matching the project's structural needs. Environmental impact, minimizing adverse effects on the surrounding environment. Now next move on to the injection parameter. As a part of grouting design consideration, pressure, flow rate and volume of the grout are the parameter for understanding which type of injection parameters. In this, controlling the pressure to avoid grout or fracturing. Coming to the flow rate, ensuring sufficient grout delivery while avoiding excessive pressure buildup. Now move on to the volume of grout, calculating the required amount based on soil void ratio and project specifications. So in these injection parameters, we have to understand the pressure, flow rate as well as the volume of grout. And the next design consideration we have to consider, that is the grouting patterns. It is determine the in these we have two different types of grouting patterns. The one is injection point spacing and the next one is sequence of injection. Injection point spacing and sequence of injection. In this, determining optimal spacing to achieve uniform treatment. And the next one is planning the order of injections to ensure even distribution and effective treatment. And next one is equipment and methods. In this, various equipment we are using for various methods. The one is injection pipes. In this, high pressure capabilities for deep injections and the progressive cavity pumps. So consistent flow rates and suitable for viscous grout. The next one is mixing plants. Batch mixers, continuous mixers. Coming to the batch mixers, suitable for small to medium size projects, offering precise control over mix proportions. Continuous mix, coming to the continuous mixers, ideal for large projects, providing a constant supply of grout. The next one is drilling rigs. So rotary drills, percussion drills. In this, common for creating injection points in various soil and rock types. And these kind of percussion drills effective in hard kind of rock formation. And the next one is monitoring systems. Pressure gauges and flow meters and computerized control systems. These are the two different types of monitoring systems are there in this earth grouting. Pressure gauges and flow meters, these are real-time monitoring of the injection parameters. Coming to the computerized control system, automated control and data logging for precise grouting operations. And the next one is quality control and testing. Coming to the quality control and testing, in this it is the one of the important steps we have to understand. This is very important step and it is required for getting the better performance of the grouting, for understanding the performance of grouting. So in this pre-grouting tests, soil borings, determining the soil strata and properties, permeability test, assessing the initial permeability of the ground, laboratory analysis, testing grout materials for strength, viscosity and setting time. These are the pre-grouting tests we have to conduct for assessing the properties as well as the understanding the how the properties are reacting based on the laboratory analysis. This is the pre-grouting test we have to conduct for understanding about the soil properties of that wherever we are grouting. Now the next one is during grouting. At the time of grouting, we have to understand the monitoring injection parameters and recording those grout volumes. Because of the monitoring inspections, we have ensuring the pressures and flow rates are within the design limits. So we are going to design how much pressure is required for that particular grouting. So during the grouting period, we are going to monitoring. It gives the better results and understanding about the design, and we are in line along with the design limits. Next, recording grouting volumes, tracking the amount of grout injected at each point. So post-grouting, during the grouting, next pre-grouting, these are the things. So pre-grouting, we have to understand the soil parameters. At the time of during the grouting, we have to understand the processes, the flow rates, whatever the pressures, we are ensuring they are within the limits, and we have to understand each and every point of the grouting process we are going to understand. Next step is the post-grouting test. So in this, coring and sampling, permeability test, load test. It's in some of the cases we have to understand after grouting, we have to understand the situation of the things. We have to understand what are the properties, parameters, like that we have to understand in that particular how the quality is there, and the test which type of test gives the better understanding comes under this post-grouting test. Coring and sampling, in this extracting some, we are going to core, extracting some portion to examine the grout distribution and its strength. And next one is the permeability test, measuring post-grouting permeability to ensure effectiveness. The next one is load test, assessing the bearing capacity of the treated ground. Like this, we are going to understand the quality control and testing of modification which is done at depth by earth grouting. So coming to the some of the case studies and their applications, the deep foundation stabilization is one of the case study. Example, grouting for skyscrapers, foundation in urban areas with the deep along with the weak soils. So once we have done this grouting, the outcome is increasing bearing capacity and reduced the settlement. The next one is the tunnel construction is one of the case study. For example, pre-excavation grouting in weak rock formations to prevent water ingress and collapse. Such cases, once we done this earth grouting, the outcome is safe and efficient tunnel excavation. And one more case study we may observe, that is dam foundation improvement. In that, grouting existing dams to reduce seepage and strengthen the foundation. The outcome is enhance the stability and longevity of the dam structure. And consider one more case study, that is sinkhole remediation. In this, filling voids and stabilizing soils in the weakest region prone to sinkholes. In this, prevention, sinkhole formation and protection of infrastructure. These are the some of the case studies and how we are applying the grouting. Coming to the advantages and limitations, in this, versatility, customizable, effectiveness is the advantages of the grouting. So applicable to a wide range of soils and rocks, and also based on the various techniques and availability of the number of various different kind of grouting materials, we are going to utilize those all the possible ways. In this, we are going to understand the specific project needs. So like this, we are going to understand this advantage. The next one is effective. So in this, we are going to the specific needs. Now coming to the effectiveness, significantly improves ground properties, enhancing stability and load bearing capacity. These are the some of the advantages: versatility, customizable and effectiveness. Coming to the limitation, cost, complexity, environmental concerns. So can be expensive due to material and equipment costs. Complexity requires skilled persons and careful planning. Environmental concerns, potential for groundwater contamination if not properly managed. These are the some of the considerations we have to understand before doing the earth grouting. In future developments also required for this earth grouting, that is innovation in ground materials. So eco-friendly and sustainable grout formulations, self-healing grouts that can repair cracks over time, and advanced injection techniques are also the development is required. Automated and robotic systems for more precise and effective grouting. Real-time monitoring and adaptive control systems using AI and machine learning. Enhanced monitoring system and testing. Improved geophysical methods for pre and post grouting assessment. Integration of the remote sensing technologies for real-time data collection. Final conclusion. Summary of this: modification at depth by earth grouting is critical technique for improving subsurface conditions in various engineering applications. In this, successful grouting requires through investigation, careful planning and precise execution. Ongoing research and technical advancements will continue to enhance the effectiveness and efficiency of deep earth grouting techniques. These are the web references we may consider for this grouting. And thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.